Barova, and I will be presenting my assignment for topic 7. It's ANOVA testing and linear regression. I'll share my screen and we'll go ahead to my Jupyter notebook. So task 1, I should find a dataset with one or more categorical variable and apply ANOVA. So here my data set has 3 categories. These are octane levels, gas levels of octane, and corresponding to the horsepower. So these are horsepowers for octane 87 and 171. Each time each row represents a corresponding horsepower. And my question is, does a different level of octane affect the horsepower? Or in other words, are the means of octane of these different categories are different? So firstly, we can simply print the means, and as we can see that for octane 87 it's 169, relatively 175 and 182. Already we can say that their means are different. It means their effect on horsepower is different. So there is an effect of a level of octane, but that is not enough. So the question is this a statistically significant difference? Can we apply it to the populations coming from the sample? So here I'm performing ANOVA test, and here we have our F statistics and p-value, and as we can see, p-value is really low, and we can say with the significance level of 0.05, and our p-level is way lower than that, and then we can reject null hypothesis, and we can assume that one of the means is different. But how different? Again, the same question, is it significantly different? Here, to have further details, we can use the linear model, and here we seamlessly go to the second task. We're applying linear model. So first, we will try to build a model. So we will try to convert it. So this function will be a long data frame with a column containing the octane type, and another here it's going to be another horsepower. It's going to be our dependent. So octane model is our independent variables, and horsepower is a dependent variable. And here we can see our model. So octane model will affect the horsepower. And now we can recast it as a linear model. Now we can apply OLC method, and here I try to find the coefficients, and I have only 2. I skipped 87, but here already we can see that coefficients are not 0. It means they have effect. Octane 91 and 89 have effect on the horsepower. And here we can look at the further details. So what is F level? What is, we don't see the means of squares. So here we are bringing the means of squares and total, and then we can interpret the result. So here we can see our result. And as you can see, so sum of squares, we know that this first row represents the means between the groups, and the second row is means within the group. So we know that F value is the ratio of means between ratio of the mean of between group divided by the mean of within the group. It is very important. So the bigger F value is, the more we are confident to reject the null hypothesis. And here you can see we have our degree of freedom. We know that we have 3 levels, 3 categories, and we can say it 3 treatments, and degree of freedom is 3 minus 1, it's going to be 2. And here we know that we have our degree mean is equal to sum of squares divided by a degree of freedom. So we can see here is our mean. And as you can see, mean between the groups is much higher than the mean of within the group, which means F is going to be high, which is good in our case. So, and this is F value, and we want to compare it to F critical value. So to find the F critical value, again, I implied Python. So with the significance level of 0.05 and degree of freedom between is 2 and within is 27. So our F critical value is 3.35. So as you can see, it is way higher. So it is in the reject area of the right-tailed model. So then we can reject. It means we reject. And here we have assumptions, and I am going way more than my limit of time. So here we have assumptions for ANOVA and linear regression. And the last part is the research question and conclusion. So research question was to investigate the impact of changes in octane gas on horsepower. Does it have an impact? And specifically, we are interested in understanding, is there significant difference in horsepower across different octane categories? And according to our results, we have really high F value. And as we saw, it is higher than F critical value. And our P value was really low, which makes us to reject the null value, which state that there is no difference in means of the categories. But now we can say that there is a difference. So our conclusion is that we reject the null hypothesis, and it is statistically significant. So yeah, we reject that. In the end, given the high F value, we reject null hypothesis, indicating a statistically significant difference in mean horsepower among the difference of octane categories. So yeah, in practical terms, this suggests that the octane ratings of gas has a substantial impact on horsepower of vehicles. So thank you. Bye.